Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a different kind of reaction in aromatic chemistry. Of course, this is going to be a reaction pertaining to the nucleophilic aromatic substitution reaction. We had looked earlier in some of our videos on the reaction of electrophilic substitution aromatic reactions, and we saw how different substitutional levels of the benzene molecule can be affected, or how we can be able to define the product that is formed from the nucleophilic aromatic substitution reactions, looking at it at the different substitutional levels. So for this nucleophilic aromatic reactions, we're going to see the influence of a nucleophile on a substituted benzene. Of course, as we said, that these substituents are going to determine the reactions of the compounds which are formed. So without further ado, thank you and welcome. So as I've said, we're going to look at the nucleophilic aromatic substitution. Nucleophilic aromatic substitution. And as we've said, this is one of the reactions that takes place, or which of course happens with the substituted benzene products or derivatives. And we're going to look at an example and see on how it is going to influence the reaction of other subsequent substitutes that are going to come in onto a substituted benzene. So in this case, as we said in one of our videos on our previous discussion, we talked about the concept of a nucleophile. And of course, from the definition of an electrophile, we had said that an electrophile is an electron-poor species or molecule. For this case, a nucleophile refers to a species that forms bonds by donating an electron pair. So this one forms bonds with other, of course, compounds or other elements by donating an electron pair. So this kind of a species that donates electron pair during bonding is what we call a nucleophile. And in this case, in our discussion, we're going to use this particular kind of a symbol to denote a general representation, or just give a general denotation for a nucleophile. But in this case, in case we need to mention a specific molecule, we are going to draw its structure for that case to represent it. So for a nucleophilic aromatic substitution, it's a reaction that is the displacement of a leaving group from an aromatic ring by a nucleophile. So of course, we're going to see different categories of what we're referring to as a leaving group, because sometimes when we have a substitution on an aromatic ring like benzene, there are other groups that, of course, during a chemical or just a reaction rearrangement, during a substitution or elimination reaction, there are some of these substitutes that leave this structure or a molecule of the structure due to the nature of the reaction, and that is what we refer to as a leaving group. Examples of these leaving groups are like the chlorofluoro, bromo, and then we can talk of this, basically the halides groups that we are talking about, but we shall mention and list a few. Of course, I've just given an example of some of the leaving groups, especially when there is a substitution at the para or other position of the benzene ring, and this particular kind of molecules that are attached to the ring are likely to leave. So in this case, I'm going to have a general, or just a reaction that is going to represent a nucleophilic aromatic reaction that we're going to use in our discussion for this. So I've said that a nucleophilic aromatic substitution reaction entails the displacement of a leaving group from an aromatic ring by a nucleophile. So in this case, we are going to, this reaction takes place in the presence of ammonia. So in this case, it's going to give us the nucleophile that is going to react with this substituted benzene in order to come up with the two products that we have listed. So that's a substituted benzene, of course, with a displacement of the chlorine, and the substituted with the nitro group. So this is the chloro group has been substituted. That is why it's known as a substitution reaction. So this is to the formation of that ammonium chloride, and this is another product, of course, which has been substituted. So this one occurs in the absence of in the presence of a nitro group, as we have indicated, because if the nitro group is missing, then there will be no reaction. This is because this group is needed to stabilize the negative charge intermediate in this kind of a structure. So in that case, we're going to look at that when we are going to do a reaction mechanism for this kind of reaction. So in this case, I just have a sketch of the reaction mechanism so that we can have a discussion. So as I've said, in this mechanism, the negative charge, that is the nitro group is needed to stabilize the negative charge intermediate. We talked about the concept of an intermediate. So in this case, I'm just going to demonstrate using this, of course, in explaining this reaction mechanism. So the reaction is moving in that direction from this one to that product, and of course this one, which is ammonium chloride, it's an ionic compound. So in this case, we'll have a nucleophile that is, because we have talked about this reaction taking place in the presence of ammonia, so we shall have a nucleophile from this ammonia to come and attack this ring double bond at that point, and then that one will just move that way like that, and then this bond will open up, and then we shall have a resulting product. It is, of course, the second intermediate, and then for that case, this bond will just get to that part, and then we shall have this one moving to the ring, of course, molecule, and then we shall have this one moving here, and then the chloro part will move away, and that is what we were talking about, the leaving group, which is the chloro part. And then the third intermediate, of course, in this sense, we are going to have the chloro group, which is a negative leaving at that intermediate, and then next we shall have, of course, another nucleophile attacking that intermediate, of course, by taking away the proton from this part, and this point will come here to stabilize that, and then we shall have the final product that is going to form, which is, of course, a substituted nucleophilic substitution product that is forming with ammonium chloride. Sorry for that. So in that case, that's how the product is going to be formed, and we shall look at different kinds of nucleophilic substitution reactions in these aromatic compounds, of course, in order to supplement the video that we have discussed. So in that case, we shall stop there for today. Thank you guys. God bless you.